Okay, so let's kick things off. So one of the new features added to the program is the resources page, which you see in front of you here at the moment. So when you upgrade from your current version to this latest release, you'll see this getting started resources page displayed in front of you, which gives you some background information in the help file. There's a design cooling water system split into two parts, and there's a gas collection system design, which is worked through in step-by-step processes, so you can get a clear understanding of how to use the software effectively. There's also a number of YouTube videos on our YouTube channel. The email address for our technical support department. If you have any queries around getting additional calculation modules, so for instance, if you had a liquid and gas module and you wanted to carry out some two-phase calculations, you can contact us at sales@fluidflowinfo.com, and Brian will get back to you with some further information on how you can upgrade to include the new modules required. We also have some information here on product training and our engineering consultancy department. So we've completed a number of training courses throughout the world this year, and we have completed a number of engineering consultancy modeling projects for various existing customers and also new customers that we acquired this year. Okay, now sometimes people, when they load up the new version of the software, they close the resources page and then they're not sure how they can reload it, and it's very simple. You just select help and resources, and there you have it once again. Okay, so that's the resource page. So let's look now at one of the other new features, which is templates. So for instance, if you had a particular model that you would use repeatedly, you could make it into a template. Or if you had a pump station or a valve station. So for instance, let's build a sample pump station using steel pipe. Okay, so we'll draw this. We'll just create two pumps in parallel, and we'll create this as a template. So I'm just building the model as I usually do, and you'll also see in this latest release how the cursor changed to the green tick symbol, and that just means it's safe to terminate the new pipe connection. Okay, so I'll just reposition my little red dot or my branch for my T's, and now I'll add in a few pumps. So we'll just add in a few auto boosters in this case. We'll stick in a few isolation valves. And we might also have check valves, so we'll just add a little check valve in here, and always obviously take care to ensure the discharge side or red dot position has been set correctly for the flow direction elements. Okay, so here's our little pump station. I could resize some of the pipes if I wanted to, but because I might be modeling this pump station in different systems with different diameters, I'm just going to leave them as they are for the moment. Okay, and now I just select File, Save as Template. So give it a name. So let's call it Pump Test. Save that, and then I can just close down the flow sheet like so. Okay, so let's say perhaps I'm working on an existing system, and we'll just create one here very quickly. So we might have this little piping system with a number of connections, and now I want to add in a pump station here to connect into this open pipe node number 4. Okay, and all I do is select File, Insert Template, select the pump test file that I just created, open, and now I can paste it in. And I can reposition it like so. Oops, my computer slowed down on me a little bit. Let's just drag it down a little bit to show you this other little feature. So I'm going to scroll down, and what I want to do here is I want to connect open pipe node 14 to open pipe node number 4. And all I have to do is click on one of the open pipe nodes, position it directly over, and you can see the green tick symbol has reappeared, and I can drop it, and now it has automatically fitted a bend for us. Okay, and you can create as many templates as you want for your projects, and it just allows you to speed up the design and modeling process. One of the other new features included as well is You're probably all familiar with creating models, and occasionally the bend doesn't appear as you would expect it to see in a normal system. So if I just click on this pipe node, I can select Edit and Rotate Node. Now you can see the pipe or the bend has rotated and it appears as you would expect to see. So I'll just do that again. Edit, Rotate Node. I'll do it once again. And this applies to both orthogonal and isometric view. And I'll just do this one. And the alternative way of doing this is to select Control and the letter R. And now you can see I'm just holding the Control key and I'm repeatedly selecting the letter R. Okay? So that just tidies up the model a little bit for you. So I'll just close out of that for the moment. And now I'm going to look at a relief valve system, because the new version of the program allows you to automatically size relief valves and bursting discs to both API and ISO standards. And that's for liquids, gases and two-phase systems. Okay. Previously you could model a specific manufacturer's relief valve in a system, which you can continue to do, but you can also now auto size. So this is an example taken from the API standard, page 44. It's example 3622. And here we've got a hydrocarbon mix of butane and pentane. And it tells us here the molecular weight of this mixture is 65. We've got a vapor flow rate of 53,500 pounds per hour. The relieving temperature is going to be 348 Kelvin. The relief valve set pressure will be 75 psi gauge. The back pressure is 14.7 psia, or 1 atmosphere. The permitted accumulation is 10%. The relieving pressure is 97.2 psia. And you can see when we work through the calculation that the hand calculation gives us an area of 3179 millimeter squared for this particular relief valve, and it's used a discharge coefficient, or KD, of 0.975 in this case. So we're just going to build a sample model of this system in FluidFlow and just compare the results that we get to see how well they correlate. Okay, so I've just plotted on the information that we just looked at there from the slides. So I'm just going to drop in my little boundary node, followed by a relief valve, and my final exit boundary node. I'll connect them together with the steel pipework, like so. And we said the surface pressure was 67 kPa, absolute. The relieving temperature was 348 Kelvin, so 348 Kelvin. And obviously we've got to create a new mixture, in this case a new hydrocarbon mix, and we can do that quite quickly. So we'll just select database, fluids, new mix, and let's call it Webinar gas mix. We're going to fix it to gas phase. I'm just going to proceed with a mixture by weight percent. You can choose by mole percent if you wish. But for speed, I'm just going to create a 50-50 ratio mix of butane and pentane. And I'm just double clicking each of these fluids to add them. Alternatively, you can select this arrow. So pentane, select the arrow, and then it goes. So I'm just going to select 50%, 50%. Our total sum is 100%, which means we can select OK, and it's applied. The software has applied the mixture rules. Click OK to complete the addition of the gas, and now we just assign that new fluid to this system. So Webinar, there we are, Webinar gas mix. OK, it's now added to the system. For the relief valve, the set pressure was 75 psi. Gauge. The required flow was 53,500 pounds per hour, and the discharge coefficient was 0.975, and the KB, or back pressure correction factor, is 1 in this case. The back pressure was 1 atmosphere, so we can leave that, and it's static pressure that we have to assign. And then finally, we need to define our pipework conditions. So we're going to make both pipes 6-inch by multi-selecting, holding the Shift key, and then choose 6-inch. And what I'll do is I'll make the upstream pipe 1 inch in length. So make that 1 inch, and then make this downstream pipe 1 foot. So now we're ready to calculate. The API result was 3179, so let's calculate to see what happens. Okay, the software has solved the system in 25 iterations. We've got no warnings. If I click on the relief valve and look at the results, we can see the calculated size is 3149 millimeter squared, which compares well with the hand calculation. There's a slight difference in result, and that can be attributed to a number of factors, such as the physical properties of our gas mixture is going to be slightly different to that in the hand calculation, because we created a very simple 50-50 ratio mix. The software doesn't assume gas ideality, but solves for real gas conditions, as you probably all know, using an equation of state, and you can choose from 3 equations of state. And also the API hand calculation is based on solving the relief valve in isolation. It doesn't take into consideration any connecting pipework, whereas FluidFlow has solved this system with the pipework connected, as you can see there. But the key thing to bear in mind when solving this system is, if I look at the input for the relief valve, the pressure loss model is API, and we said at the beginning we can also choose ISO standards. But when choosing API, the API standards have a list of standard orifice sizes in letter form. So what the software does is, based on the calculated size, it now suggests the next standard orifice size suitable for this system. So orifice size P, or 3120 millimeters squared. So we can now look at the standard size, and we can go back to the input tab, and we can turn the auto size function off. And now we could select from a standard from the list of standard orifice sizes and choose orifice P and select the particular model we're going to use, the relief valve name and so on, and then model that in the system. So it's a very fast way of allowing you to solve a relief valve system. Okay. So that's really covers the relief valve feature. What I might do now is just move on and have a quick look at the slurry feature. So I'll just go back here one moment. So this is just a tails pumping system. Okay. Now previously the software included 3 pressure loss correlations for slurry systems, or settling slurry systems I should say, Durand, WASP and WASC, Wilson, Addy, Selgren and Clift. But we've added 2 additional correlations, the Selgren-Wilson 4-component model and the Liu de Jong pressure loss correlation. Okay, and what that means is up until now modeling software has forced engineers to choose to either model a slurry system as a heterogeneous settling slurry or a non-Newtonian non-settling type slurry. But in reality, a slurry can often exhibit a combination of these 2 flow behaviors. So now we have 2 new correlations which takes the two flow regimes into consideration in the solution process. So it means you don't have to make that difficult decision at the project outset. So the 4-component model, it effectively classifies the slurry into 4 components based on particle size, with each component possessing different friction loss characteristics. An empirical comparison has indicated a very high level of accuracy, particularly with tailings and paste systems. And the second new correlation, the Liu de Jong method, was developed by Professor Liu in China, who has over 50 years in slurry pipeline design. And in this modeling technique, the slurry is classified based on the particle concentration gradient across the pipe cross-sectional area, and it's essentially a 2-component model where it splits it into a heterogeneous region and a pseudo-homogeneous region. And also if I look at the boundary now for this particular system, we can see often at the beginning of a project, you might have very limited particle or solids information. And in this case, we've a solids concentration of 50% by weight of iron ore. We've got a D50 value and a D85 value. And if we now look at the chart, the software creates the Rossum Rambler distribution, particle size distribution chart. You can see our D85 and our D50 point on the curve. But because it's plotted this new curve for us based on these 2 points, this allows us to use any of the 5 correlations available in the program. Whereas, at the beginning of a project, up until now, if you only knew the D50, you would be forced to use the Durand correlation. Whereas if you knew the D85 as well as the D50, you could choose the WASC. And obviously, if you had the particle size distribution information or your sieve analysis, you could use the WASP method. Okay, so this curve now allows you to choose from any of these methods, and you can compare then the calculated results between each. Okay, so that really covers most of the main features in the latest edition of the software. I will email everyone with a copy of a little slideshow covering the topics that we looked at here this morning. And I'll do that this morning after this webinar. Please keep in mind that we have another new version being released before Christmas, version 3.4, and this new release will allow you to automatically size control valves, auto boosters sized on system pressure requirement, pressure controllers, differential pressure controllers, orifice plates. All these devices you'll be able to size automatically. So at this stage, does anyone have any questions? Any questions? Hi, Cornet. You can use scripting to perform some of the analysis that you've seen in this presentation. Scripting is a much more powerful tool in that you can carry out dynamic analysis of whole systems and assess fluctuating operating system profile or demand profiles or pressures and so on in the system, whereas the new features are sort of independent of that, and you'll be able to, from the input tab on the data palette, automatically size the orifice plates and the control valves and so on and so on. So it's a separate little key feature that engineers can use. Have you any other questions, anyone? If anyone would like a one-to-one webinar in the coming days or weeks, or has any further questions that they think of after this session, by all means you can contact us at support, which is support@fluidflowinfo.com, or alternatively you can contact myself, Jay McLoone, that's JMCLOONE @fluidflowinfo.com. Hi, Corny. Yes, I'm just reading your question here. Yes, you will be able to use scripting to update the system operating profile based on the auto size results. You would be, yes. Okay. If there are no other questions, we will end for today. Thanks once again for taking time out of your busy schedule to sign in on the webinar this morning. I hope you found it informative and useful. And if there's any features that you feel would be of benefit to engineers, by all means, please don't hesitate to contact our office and let us know. We'd be delighted to hear from you. Okay. Thanks very much, everyone. Thank you.